On a Thursday morning, this is one of my favorite spots of the week because I get to learn something. In a 4 or 5 minute chunk, I learn more about the technology that is shaping our world and moving quickly. How much do you know about quantum computing? Well, here's a little session of Quantum 101. Now, you thought that AI, artificial intelligence, was coming at us fast. Well, here's what's right behind it, and it starts with a Q. To get some details, we're happy to have Christa Hill with us this morning. And, of course, Christa Hill is CEO and co-founder of Tacit Product Leadership. Good morning to you, Christa.
Good morning, everyone. I'm so excited to talk about this because it is not a super approachable topic. It definitely sounds like, oh, that's not for me, but it is. So we're going to break it down for everybody today.
And I love that because, I think sometimes people's eyes glaze over, but it's important to be in the know. So let's break it down, Christa, from your vantage point, why we should know about it and what it's all about.
Well, there is a huge wave, like you were saying, coming in behind AI, and it is called quantum. And I want everybody to know Alberta is actually a very important global hub for this development and this research, and not everybody knows that. So we've got the University of Calgary, we've got the Quantum City Initiative, and of course, our federal government has just announced new funding for more research into quantum, which means quietly in Alberta, a lot of that investment is going to be coming our way, and it could represent a huge leap and take us way beyond the limits of today's AI. But before we get into all that, I just want to explain what the heck is quantum, right? You've probably heard this term before, but really we have no frame of reference for it in the real world. So I want everybody to visualize, we've been teaching computers to think like us, using ones and zeros, yes or no, this or that, right? We need buckets for everything. So you remember watching The Matrix and the ones and the zeros would flow down the screen, right? And this is called binary code. And this is how every email, every photo, all the AI models you've ever used, this is what they're built on. So an example for that in the real world and how our brains work is how we categorize humans, right? Male, female. These are binary categories. And we need these categories in our heads so we can make sense of the world around us. And because of that, we've created AI to need that too. So it's really a reflection of how humans process and categorize the things around them in their world. But nature doesn't need that, okay? It doesn't see the world in these neat little boxes. It's messy, it's fluid, it's uncertain. It can see some things and they can be in two categories all at once and be the same thing. Like a particle and a wave here, there, all at once. That's what quantum computing taps into. It's nature's code base. So instead of the world us forcing everything into ones and zeros, we're finally learning how to create code that follows nature's patterns, not just the ones that we see. So instead of bits that we use in computers, we use qubits in quantum, and these tiny little quantum states, they can represent many possibilities simultaneously. So that's a huge leap, and here's why it matters in the age of AI. Right now, we're training AI models. They take massive amounts of energy. We're talking power plant levels of electricity and warehouses of all these advanced NVIDIA chips that we're all hearing about that they're going to need, right? And this is, we're hitting that wall of those AI compute limits, and we're running out of room to go faster or cheaper. So quantum could change this, because it doesn't just go faster. A classical computer, it does one thing at a time, but it does it very quickly. A quantum computer can explore millions of possibilities in parallel. So this could be a huge breakthrough in optimization and logistics, how we do our modeling, drug discovery, and yes, even AI training. So it's a big leap, but before everybody gets really excited and thinks that it's going to be a big hero, there is a little bit of a downside. Quantum has its own energy problem. This is just another phase of an engineering problem that we need to tackle. So there's a lot behind it, but I hope that sort of explains the nuts and bolts of it.
Yeah, we're out of time, but I love how you focused on, the growth in our fine province. And I think I've learned a little bit more about quantum and, of course, the marriage between quantum and AI. Thank you so much for your insight this morning, Christa. Appreciate talking with you each and every week. Thank you.
You bet.